Hey everyone, welcome back to the channel Devotion of Knowledge. Today we are back again with another coding video, and you might have seen in the thumbnail. Today we are going to discuss a concept of tree data structure. So basically, let me tell you, a total of two videos will be released. This one is of left and right view of binary tree, and this is the first video, and second video will be of top and bottom view of binary tree. So these two are the main topics that we are going to discuss, and believe me, these are fundamental topics for those who are learning trees. And believe me, the concept is really easy. You will enjoy my explanation as well as our approach towards the code as well. So please tie up your seatbelts because we are going to start with intuition plus code, and yeah, everything that one needs to know for these two particular topics, that is left and right view of binary tree and top and bottom view of binary tree as well. I thought to combine both the topics into a single video as well, but the video size will be too much, and as well as the content delivery not be as efficient as I can carry out in single video of both the approaches. So I thought, why not to go on with the single video with the two topics each. And believe me, if you know or if you understand the left view, right view is just a piece of cake, and if you understand top view, bottom view is just a piece of cake, because there will be at max 2 or 3 lines in which you have to modify the code. So yeah, that's it for the introduction part. Let us move directly towards the understanding of the question. So yes, the first one is of lead code, and yeah, a platform doesn't matter much. So this is the given binary tree to us, and we will be given root into the question or as the parameter of the function, and we are viewing this tree from the left hand side, and we have to give that how many nodes we will be able to see from the right hand side. So it will be 1, 3 and 4. So answer we have to return vector of 1, 3 and 4. So yeah, this is the main question. बस क्वेश्चन में इतना है, ज़्यादा कुछ नहीं है. अभी हमें मेनली अंडरस्टैंड करना है अप्रोच. How will we be approaching the questions? Okay, so let me first erase the stuff, and then we'll be moving towards the question. 1 2 1 2. Okay. Yeah, so this is the question given to us. Now left hand view. Now for example, if I give you binary tree like this, and I'm asking you a simple question. If I view from right hand side, you will be obvious, like मतलब यही 3 नोड दिखेंगे ना भाई, ऑब्वियस सी बात है. 1 2 और 3, इसके अलावा तो कोई दिखेगा ही नहीं. If this separate node was there, then you might see this 3 and 4. So you will be seeing these 4 nodes, 1 2 3 and 4. अभी लेफ्ट हैंड साइड का नोड कब आएगा आंसर में? लेफ्ट हैंड साइड का नोड तभी आएगा हमारे आंसर में जब इसके करस्पॉन्डिंग लेवल पे कोई भी राइट नोड नहीं होगा. द लेफ्ट नोड विल बी ऑलवेज कमिंग टू आंसर इफ एंड ओनली देयर इज एब्सेंस ऑफ राइट नोड at its level. Very simple. If someone is present here, then this particular node is present into the tree, but this node will be overshadowed or overridden by the presence of this particular node present on the right hand side of the same level. So what I am trying to say, see here, 5 node is present, but it is not coming into the answer because it is overshadowed or it is overridden by the presence of the right node at its corresponding level. Similarly is the case here as well. 2 is present, but 2's presence is overtaken, or you can be said it is shadowed by the presence of 3, and obviously root node तो आएगा ही क्योंकि इसके लेवल पे कोई है ही नहीं. Okay, so yeah, let us understand one more example and the picture will be more clear. Yes, here is the example. Node 1, no one is there, so it will be part. Now node 2 is present, but it is overshadowed by the presence of node 3 on this side. So 3 will be the part of answer, 1 will be the part of answer. Now node 4. Now there is no one on the level of 4, so obviously 4 will be the node which will be visible. So 4, and similarly there is no one on the corresponding level of 5 as well. So yeah, 5 will be also there. So we have to simply check the nodes on each level. Simple. Means we will be going doing a question through DFS. So if I want to solve this question using DFS, I'm standing on this node. Let me initialize answer. Now yeah, one thing to observe, how many elements will be there into our answer vector? Obviously जितने level है उतने nodes तो दिखेंगे, तो it will be of size of level. Okay, so for example here it is as 4 levels are there, so 0, 1, 2 and 3. Yeah, corresponding indexes are there marked. Now root node will be always there, so 1 will be always present. Now if I use DFS, so in DFS what I will be doing, I will be going through as much as possible on the left hand side, and then I will be going to as much as on the right hand side possible. So if I am going on the left hand side, so I will be reaching this node as a base case. So what element is this? 5 is. So on level 3 5 is present, so I will definitely write 5 into the, I will write that element. We will treat level as our index. Okay, so now it will go on here. So what is the next element? It is 4. It is at present at level 2, so on level 2 we will be writing 4. Okay, now it will return to here. Now element 2 is there on level 1, so we will be writing 2 on the level 1. So level 1 तो पहले से 1 है. Okay, we are done with the left side of the depth first search. Now we will be going on the right hand side of the tree. Now on the first level 3 is present, so we will be writing 3 on the first level, because yeah, 2 was already present, but now 2 is overtaken by 3 because it is present on the right hand side of the 2 on the same level. So we will be writing 3 over here. There is no other element on level 2, no other element on level 3. So this is our final array that we have to return. 1, 3, 4, 5. This is the answer that we have to return, and this is the right hand side view. Yeah, this is it. So let us first move towards the writing of the code, and just a second. Yeah, so let us go and write the code. Yeah, recording is still going on. How much time is there? Okay, it's 8 minutes, so we are running on time. This is the code, and we will be returning the answer. Let me zoom a bit. Yeah, but right now, as I told you, the number of size of the answer array will be equal to number of levels that we have in our array, 1, 2, 3 and 4. So but right now we are given only 3, so we don't know the what's the size of the tree. So we have to check first the what is the size of the tree. So int let us say ht equal to -1, and let us say a temporary variable. Okay, there is no need, and let us call dfs1 for height, which will take root as a parameter, hgt as a parameter, and 0 as a parameter. Now we will write all the functions inside our private, and it was void dfs1. It will take 2 parameters. One is the node of the tree. We will be taking parameter by the name node. Another one is int and hgt because I am taking it by reference, and another one is int level. Now we will write base case if node equal to null. We will be just simply returning 0 is passed. Yes. Now we will check if node star left is defined, means it is not null, then we will be calling dfs1 to that particular part, node star left, HDHT is a variable and 1 plus level. Similarly, if node star right is present, DFS1 will be called node star right HGHT as it is 1 plus level, obviously. Now when we come at each level, we have to take maximum of height equal to maximum of HGHT and LVL, because LVL is the variable which is increasing on each and every recursive call. So it is increasing, so at each level we have to make sure that we are taking maximum, and it should not be considered on the base case. So we are writing base case for the on first line, and next we are writing the code. So this was the DFS for calculating the height of the tree. And those who don't know, please have some decent knowledge how to calculate height of the tree. Now vector int of ns, here we are passing 0 1 2 3. So height of the tree will be 0 base, so we have to declare answer vector equal to size height plus 1 and each every element. Okay, right now we are not writing any element. Now we will be calling just DFS2, and we will be passing root and ns vector, and yes, I think, and yes, level, initial level will be 0. Yeah, I think this much is enough. So void DFS2, what we'll be taking as a input, node of the tree, then vector named answer, we will be taking it as a reference because we'll be making change into the same vector, and int LVL, and just use more space. Yes, here similarly base case, if node equal to null, return, and on the left hand side ns of level equal to node. How we can get the value? Node well. Similarly, node star left is defined, DFS2 node star left, then what's the next parameter? ANS and plus level, I would say, not plus 1 plus, because level is there. So on the next call, when we will be calling, it will be 2 plus level. Similarly, we will be copy pasting the same code. If node star right call, okay, some error, control X, node star right and plus level plus 1, and yeah. And so as I told you, here initially this 2 4 and 5 will be on the places here, 2 4 and 5. Now when the right hand side of the tree will be called as DFS, so corresponding places will be overshadowed by the right element present on the same level. So 3 will be taking the place of 2. So yeah, this is the main logic. Let us run the code, whether there is any error or not. I hope there should not be any kind of error. Yeah, for the first time in the YouTube video, the code is running for the right path in the very first time. And yeah, accepted. Space time complexity 100%, space complexity 95%. So that is the most optimal approach. और आदमी क्या ही करेगा भाई, ठीक है, क्वेश्चन में लेफ्ट राइट तो होल करना ही पड़ेगा. And so yeah, this was the case for right view. Now what will be the change in the concept for left view? Let us erase all these things, delete. Let me take a fresh screenshot, print screen, and now let us take this one because this is a more interesting example. Yeah, we are pasting it here, and yes, now whenever we want to see from the right hand side, what will be the answer? 1 2 4 5. 1 2 4 5 is the answer. Now what's the key difference between the previous approach and this approach? The key difference is that when you are watching from this side, initially we were doing DFS on this side, and we'll be calling the DFS for this part of the tree. So if elements are present on this side of any corresponding level, they will be taking place of these elements present on the same level. But as it is left hand view, what will be the change in left hand view? 1 2 4 5. Yes. What will be the change in left view? Initially we will be taking DFS on right hand side, and then if elements are present on the same level like this, they will be taking place of the corresponding element present on the same level. So what's the change in the code? Nothing. Just the change in the code that we'll be doing is we'll be just erasing this part from here in the call, and we'll be just pasting this part. Now why? Because as I told you, we have to take these elements first. So we'll be calling DFS on the right hand side first, and then we'll be calling DFS on this part of the tree, because these elements will be taking the place of corresponding elements present on the same level. So just the mere change, node slash right will be coming first and node slash left will be coming second. अभी कोड ऐसे दिखा दिया, चल नहीं रहा, कैसे पता? तो मैंने सेम कोड पहले से लिख के रखा है. लेफ्ट हैंड साइड का क्वेश्चन है Geeks for Geeks पे. The only change in the code is there. Node slash right is called first, then node slash left, and as you can see on submitting the code, it's taking so much time. Yeah, you can see all the test cases are getting passed, and yeah, this was the main approach. And yeah, we are done with the concept. Left view and right view. Time complexity, obviously O of n, because we will be going and visiting each node. In space complexity, obviously O of n, क्योंकि हमें आंसर रिटर्न करना है. So O of n is the time complexity as well as space complexity. So I think I should conclude for this video. In the next video, we'll be doing top and bottom view, but this will be the next video. Till then, please give it a try for left view and right view of tree, binary tree, and these are important questions as well. So we will be meeting in the next video very soon. Till then, keep learning, keep hardworking. Thank you very much.